All right, today we're going to create a blind flange. Yes, there are library parts that you can pull this from, but this will explain how the revolve functions work. Not only revolving the profile of the flange, but also using a circular pattern to revolve the bolt patterns around. In another video, I'm going to show you how to just extrude a flange, and we can kind of compare the differences between revolving and extruding. So the first thing we're going to do is go up to File, go to New, and we're going to start a standard IPT. First thing I'm going to do is go into the parameters, this little F of X button up on top here. The length, we're going to just go ahead and fill this out. We're going to put in the length is the overall thickness of the flange itself, which is 1.3125 or 1 5/16. The width I'm actually going to use as the diameter, which is 9 inches. And here's a nice little feature. If you don't know, like this, we're putting in some dimensions for, like, width is the diameter of it. You can come over to the comment and put in outside diameter. The length we can put in here the total thickness of flange. That way you just got kind of a record of what these are actually driving. I like to keep these in here because the drawing is pulling this information, this little export parameter. It's actually pulling this information so that when we look at the drawing, it has this information available to us. The thickness, I'm actually going to do the thickness of the flange itself, not the raised face part of it, not the weld neck part of it, but the thickness of the flange itself, which is it's 15/16 minus a 16th for the raised face. So we're going to go 0.875 and type in here thickness of flange body. Down below, we're going to go add numeric. Oops. Try that again. Add numeric. And we're going to put in, let's go raised, capital, raised face thickness. It's 0.0625. Raised face diameter. And that is 6.1875 or 6 3/16. We're going to go bolt circle, which is 7.5, and bolt hole quantity. Now here we need to change the units because this is a quantity, not a actual distance. So we're going to go in and click on unitless, and again that's underneath of unit type. Click on that, click on unitless, and select OK. Now we need to change that to 8, and you can see that it says 8 UL for unitless, and we're going to go bolt hole diameter, which is 3/4 of an inch, and that should give us a majority of what we need. We got one more dimension I need to look up here, which is the weld neck itself. So 4 is, let's make this weld neck. Oops. Let's go weld neck diameter. And let's add a variable. Let's go in here and say we know that the pipe coming through is 4.5 and it's slightly oversized, so we'll also need to put an ID in there. So let's go ahead and add another one. Let's go flange ID. So that's 4.57. Now we can take that and go in flange ID. You can see how it changes from red to black. Black meaning that it has accepted that. So I'm going to put plus 0.125 and drive that dimension based off of this flange ID. Now we've got all of our variables pretty much set up to create the profile for the flange. Click done, and now we need to start a sketch. So you can either come up here and start picking a feature, or you can hit S for sketch and pick your plane. I'm going to pick on this plane right here, and as always we've got to rotate this so that the top is showing correctly. And I'm going to start with a line, come over here to my construction line, and I'm actually going to pick on center line. And I'm going to go just above the origin, come back down to that origin point right there. And what I'm doing is I'm drawing the side profile. So if you were to split the flange vertically, so you can see the cross section of the flange itself, that's what we're doing. So I'm going to come in here, click D for dimension, or you can come up to annotate and then dimension, but we're already in here, so we're going to go ahead and place that. Click on our arrow, go to list parameters, and I'm going to go to length. So this is the overall thickness of that flange. Now I'm going to come back in here, and I'm going to hit, let's go back into the sketch, rotate that, come back into line, and I want to make sure that center line is no longer selected, which it's not highlighted. The construction line isn't highlighted. So now I'm going to draw the profile. That's our raised face part of the flange. Now I'm drawing the thickness of the flange, the little weld neck, and the ID of the flange. So you can see how I've got a little bit of a gap here. I can take that point, drag it over, and connect it to that end point there. And now we need to do some constraints. I'm going to come up to horizontal constraint, pick on this end point, and pick the top of the flange. Go down to this bottom point, pick on that, and pick on the bottom. So now we have our overall thickness of our flange, and you can kind of see the profile of what that would look like. I'm going to go ahead and put the outside diameter, so that's our width. Pick on that, select that. Let's go with our raised face OD, raised face diameter. Let's pick on, let's do this one first. And we want our weld neck diameter. And we want our ID. Oop, highlight that. Go into list parameters and go flange ID. You can see I've got a little bit of an issue here. For some reason that constraint did not connect. So I want to either drag this back and connect it, and you can see that little green dot, and we're good to go there. Or you could have used the coincident constraint and clicked on the endpoint to the endpoint. So now let's do our raised face thickness. And let's put our flange thickness. Flange ID, what did I name it? I named it thick. Okay, so now you can see the finished profile. Now this looks like it's a little too thin if you ask me, so we've got a 1/16th, so let's change that. And I've got flange ID plus 1/8 of an inch, so it's taking half of that for that diameter. So let's change that to 0.375. That looks a little bit more like what it should be. Now, you can come up to 3D model and revolve it. I always use the keyboard, as you guys know. I'm going to hit R for revolve, and it figures out, okay, well, this is my only closed profile, and this is my only center line, so that's what I want to revolve it around. Sometimes you've got multiple profiles, and you'll have to select the profile, and then you'll have to select the axis. But this, it already figures this out what we want. So I'm going to go ahead and select OK, hit F6, and there's our flange. There's the start of our flange. Next thing we need to do is create a bolt pattern. So I'm going to come up to, there's a couple of different ways you could do this. I'm going to go ahead and hit S for sketch. I'm going to do it this way first, and then I'll show you another way. I'm going to do a construction line from the center point, or the origin, and drag it out. Hit D for dimension, dimension that, bring up our parameters, list parameters, and look for bolt circle. Bolt, hole diameter, bolt circle right there. And I'm going to come up here, select circle, deselect the construction, pick on the very top quadrant or the apex of that circle, drag it out and pick, hit D for dimension, pull that off, go to list parameters and go bolt hole diameter. And now it's still green because it is not constrained to the vertical, so I'm going to pick a vertical constraint up. Now here's a perfect example. See how the front is rotated 90 degrees? I'm going to have to go to a horizontal constraint instead of a vertical constraint. Now I could use a vertical constraint, but it's going to do it this way instead of this way. So I'm going to do a horizontal constraint from this point to the center point, and there we go. Now if I was oriented so that it was horizontal, I could do a horizontal constraint or a vertical constraint and it would be correct. And let me show you what I mean. Now right now it's setting down here. Our front is oriented facing towards us and horizontal, so now I could use the vertical constraint from this point to the origin point, and now we're good to go. So I can finish that sketch. I can hit E for extrude, or I can come up to model, extrude. Since I'm here, I'm going to go ahead and use that. I'm going to pick on the circle, and you can see how it's going to, if I didn't click on the cut, it's going to extrude this out 1 inch. So I could go ahead and select that. So now you've got a little stub hanging out there. I want to go back in and edit that so that it's going to cut it out. Edit, feature, click the cut command, and I want to go through all. Now I could use the 2 and pick the back surface like that, which would be fine, but really it's easier just to do through all. And you can see that it's trying to pull a cut the opposite direction. It's cutting into nothing. So I'm going to flip that so that you can actually see the hole, and then select OK. Hit F6 to bring it back to the isometric, and then I want to come up here in the 3D model and go to a circular pattern. Features, I'm going to pick on my extrusion. You can see how it highlights that in the blue. And then I'm going to go to rotation axis and pick on the center point of that. You can see that right now it automatically defaults to 6. I'm going to click on list parameters and come into bolt hole quantity. And it automatically assumes that you want to rotate that 360 degrees around the axis of that flange. Select OK, and now we have our flange. Next thing we want to do is come up to materials, and let's just do A36 for now. It automatically puts it underneath of this plate 1 profile. I'm going to change that to mill finish, which, if you ask me, that plate looks better, but again, it's harder to see when you're trying to sketch on that dark pattern. And there we go. Now we can put some fun features in there so that it looks a little bit more like a real flange. I can pick on this one, and select OK. Now we've got a flange that's actually got radiuses, similar to what you would see on an actual flange. And there you have it. Next thing, let's finish this up with a description of what the part is. I'm going to come into project. And we're lagging a little bit here. There we go. Oh, come on now. And just wait for the computer. Alright, now we're here. So come back over to the project tab, come down to the description, and we're going to go flange slip on 4.0 inch 150 pound steel. Division is A. We can go apply, and we're good to go. Now the nice thing about this, and we'll get into it in the a little bit more advanced features, is we can actually take this part and create an eye part out of it, which you could drive that from an Excel spreadsheet, and you could change this to all the different sizes of the flanges that are available. Plus you can change it to a weld neck style, a blind flange, and so on and so forth. So one part will drive many parts. So you can create a library part file.
Those are super useful, especially when you've got your own part numbering system. The library parts in Inventor, it's a little bit more tricky to change the part numbers and the descriptions, and a little bit more difficult to understand their way of picking the different sizes. So I like to use iParts, and we can cover that in a little bit later. Let's do an extrude on the next video. Instead of revolving, we're going to extrude it. That's it.